Okay, so to determine the volume of base needed to titrate a given mass of acid, this is essentially using skills that you already know what to do. So you know how to convert between a mass in grams and use the molar mass as a conversion factor to get to the number of moles. So in this case, we're going to want our moles of citric acid. And we already know that if I have a given concentration of solution, I can relate that to the amount of moles per unit volume in that solution. I can literally use this as a conversion factor because 0.16 molarity means that there's 0.1600 moles of sodium hydroxide per 1 liter of solution. Okay, so the tricky thing is we have not been given a balanced equation for this neutralization reaction. So that is step 0 before you begin. You have to write a balanced equation for the neutralization reaction. So things that can change, okay? We have been given the formula of citric acid, and very kindly, the hydrogens that are ionizable have been written on the front. And if we didn't know that, we're also told here it's a triprotic acid, which means 1, 2, 3 of the hydrogens will be ionized, okay? So those are the H pluses that are going to react with the hydroxide ion coming from the sodium hydroxide. So we've got to work out the formula of the neutral salt. So imagine that citric acid breaking apart into 3 H plus ions, and then we're going to have C6H5O7 as our anion, which is going to have a 3 minus charge to counterbalance those 3 H pluses that it's giving up. So this would be the citrate ion if you're interested. Okay, so then how many sodiums will that combine with to make the salt, which would be sodium citrate? Is going to need 3 sodiums. Okay, so we can write our equation according to the format: acid plus base gives salt, which we know is going to be sodium citrate, plus water. Okay, so do not attempt anything without a balanced chemical equation is the take-home message here. So H3C6H5O7 plus our base is sodium hydroxide. I'm going to balance this in a minute. So our salt there will be sodium citrate. So it's going to be 3 sodium plus 1 cations to balance one of the C6H7O7 3 minus. Okay, so that's the citrate anion, and then water is our other product. So in order to balance, if I got 3 sodiums here, I'm going to need 3 sodium hydroxides here. My citrate ion is balanced. What about hydrogen? So I've got 1, 2, 3, 4, 5, 6 hydrogens. So I'm going to have 3 waters as my product. So there is my balanced chemical equation. So my plan is then I've got to work out how many moles I have in 0.195 grams of citric acid, and then relate the moles of citric acid to the moles of sodium hydroxide it's going to take to neutralize it using the reaction stoichiometry. And then if I got the moles of sodium hydroxide and I've got the concentration, I can use that as a unit conversion to get to the volume, which will come out in liters. So I'm probably going to have to convert it into milliliters. So here's my plan: mass of citric acid to the moles of citric acid to the moles of sodium hydroxide to the volume in liters of sodium hydroxide, and then finally to the volume in milliliters of sodium hydroxide. So let's gather together all the equivalencies we're going to need to use as conversion factors. All right, I've got enough space. So between mass and moles, it's going to be the molar mass. So let me add that up really quick. So 3 hydrogens, 3 times 1.007-ish, plus 6 carbons, 6 times 12.011-ish. This is just the ones that I have in my head, okay? Plus another 5 hydrogens, so 5 times 1.007, plus 7 oxygens, so 7 times 15.999. That's probably enough sig figs. So the molar mass is 192.115 grams per mole. So that means that 1 mole of citric acid equals 192.115 grams. So that is my equivalency I can use to convert between mass and moles. If I look at my balanced chemical equation, for every 1 mole of citric acid that reacts, it will react with 3 moles of sodium hydroxide. So 1 mole, I'm just going to use Ca for citric acid, or will be here all day, to 3 moles of sodium hydroxide. And then to get from my moles of sodium hydroxide to my volume in litres of sodium hydroxide, I'm going to use that concentration of 0.16 moles per litre as a conversion factor. So I'm literally going to rewrite this as an equivalency, because what that molarity means is 0.1600 moles of sodium hydroxide are in every 1 litre of solution. Okay, that is literally what that concentration means. And then to get from the volume in litres of sodium hydroxide to the volume in millilitres, I'm just going to use the fact that 1 milliliter is 10 to the power of, where is my -3 litres. Okay, so that's just SI unit prefix conversion. So we can do this whole shebang in one step. Okay, so we have 0.195 grams, use the molar mass, which hopefully I calculated right using the molar masses that are for some reason memorized. So 1 mole of citric acid. Okay, so right now we're here at moles of citric acid. I want to convert moles of citric acid to moles of sodium hydroxide. So I want my moles of citric acid to cancel out my moles of sodium hydroxide to remain. Let's make this text box bigger because we know we're going to use it. All right, so look at the ratio. For every 1 mole of citric acid that reacts, it's going to react with 3 moles, if I could press the button, of sodium hydroxide. So we converted moles of citric acid to moles of sodium hydroxide. We're here. So then I'm going to use my concentration, my molarity, as a conversion factor. So I know for every 1 litre of solution, it contains 0.16 moles of sodium hydroxide. So now moles of sodium hydroxide will cancel out, giving me my volume in litres. So the last thing I have to do is convert litres into millilitres, which is just simple SI unit conversion. So let me just draw so you can verify with me that those units are cancelling out. Notice I always write moles of what? Moles of citric acid, moles of sodium hydroxide. So I know that I've cancelled out my moles of citric acid, and I know that I've got this mole ratio the right way round, because there's a massive difference between multiplying by 3 or dividing by 3, right? And then my volume in litres cancels out, giving me an answer in millilitres. Drum roll while I get my calculator, please. Let's build up some tension. That's 3 divided by 0.16. By 10 to the power of -3. Bum, bum, bum. Gives me 19.0 to 3 sig figs millilitres. That sounds like a sensible number. Okay, so make a plan, use dimensional analysis, but most of all, don't forget to have a balanced chemical equation. All right, let's have a look at another one, because I do like to do two, just to make sure we don't get any crazy stuff. All right, so this is just a monoprotic acid. I guess I did the hard example first, right? So again, we have our acetic acid here. You know what? I'm going to do another one because that's even the same concentration. That's a little bit boring, isn't it? Here we go. A diprotic acid with a different concentration. Let's get a bit more excitement in our lives. So we have to write a balanced chemical equation for this process. So we've been told that sulfurous acid is diprotic. If we did not get told that in the question, we can work it out because the 2 hydrogens on the front. If you have like an organic acid that has other hydrogens in the formula, but they're not stuck on the front, that tells you they're bonded to carbons and they just sit there. They don't do anything, right? Okay, so let's write a balanced equation then. So our acid H2SO3 plus our base, which is NaOH, gives my salt. So what's my salt going to be? Well, I've got the SO3 2 minus ion, that is the sulfite ion, and sodium is Na plus. So it's going to be sodium sulfite, which will be Na2SO3, will be the formula of my salt. And then the other thing I have is water. So let's just check that that is balanced. Sodium, there's 1 on this side, 2 on this side, so I'm going to have to do that. What else have we got in here? Sulfate is good. How many hydrogens? 1, 2, 3, 4 hydrogens. There's only 2 over here, so boom, that should be balanced. Okay, so I'm gonna need my molar mass of sulfurous acid, because I'm gonna need to go from the mass of H2SO3 to the moles of H2SO3 to the moles of my base, which is sodium hydroxide again, to the volume of my sodium hydroxide. That's going to be in litres, and then I'm going to have to convert that into millilitres. right, let's fix this a little bit because that got a little bit ugly quickly there, didn't it? So gather your equivalencies. To get between mass and moles of sulfurous acid, it's going to need the molar mass, so 2 times 1.007 for the hydrogen, plus 32.06, I think, yep, for the sulfur, plus 3 times 15.999 for the oxygen. So the molar mass is 82.071 grams, or to whatever sick things you have. So that means 1 mole of H2SO3 will, come on, baby, will weigh exactly 82.071 grams. So equivalency number 1. Equivalency number 2 comes from our balanced chemical equation. We need 2 moles of sodium hydroxide to neutralize 1 mole of sulfurous acid, okay? That's because there's 2 ionizable protons. So you're going to need 2 hydroxides. So there is our conversion between moles of this and moles of that. All right. And then to get from the moles of sodium hydroxide to the volume of sodium hydroxide, we're going to use this concentration of 0.0700 molarity, which means moles per litre. We're going to take that and make it an equivalency. So 0.0700 moles of sodium hydroxide for every 1 litre of solution. That is literally what concentration in terms of molarity means. And then we're going to use our knowledge of SI unit prefixes to know that 1 milliliter is 10 to the minus 3 liters. Boom. Okay, so let's do it. 82.0. Oh, that's the wrong mass. 0.146 grams is what we start off with as the sulfurous acid. So let's convert mass to moles using the molar mass to make our unit conversion. So right now, if I press equals on my calculator, I've got moles of sulfurous acid, but I don't want that. I want moles of sodium hydroxide, so I want my moles of sulfurous acid to cancel out. It would really help if I pressed the right buttons. Okay. Okay, so look at my mole ratio. For every 1 mole of sulfurous acid that reacts, I'm going to need 2 moles of sodium hydroxide to neutralize it. Then finally, I'm going to use my concentration, 0.700 moles of sodium hydroxide for every 1 litre of solution. 1 litre, and then convert litres into milliliters. So, yep. 1 milliliter is 10 to the power of minus 3 liters. All right, and then it's time to just slap it in your calculator. Make sure that you use parentheses if required, especially be careful with things like 10 to the power of minus 3 liters. Okay, you may need to tell your calculator that the minus is stuck to the 10 to the power of, I don't know. So we're going to end up with an answer in milliliters, which I assume is the units that ALEKS is asking for. 0.146 divided by 82.071 times 2 divided by 0.07 divided by 10 to the power of minus 3. And we get 50.8 milliliters to 3 significant digits. All right, that'll do. We've done a triprotic and a diprotic. A monoprotic's much easier. I'll let you guys do that.